This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, we're going to find the y-intercept and any x-intercepts of this parabola. Y equals x squared minus 2x plus 6. All right, always to find the y-intercept, we let x equal 0 because everywhere on the y-axis, the x-coordinate is always 0. So let's start off with the y-intercept, which is the easier one. Y-intercept, let x equal 0. All right, so if we put in 0 for x, you notice y is 6. So that means that our y-intercept, when we put in 0 for x, we got one value for y. So there's going to be y-intercept on this parabola. Now let's try the x-intercepts. The x-intercepts, we would let y equal 0 because everywhere on the x-axis, the y-coordinate is always 0. So we're going to put in 0 for y. 0 equals x squared minus 2x plus 6. Now we need to solve this equation. So this is a quadratic equation. So usually you take a quadratic equation, you just set it equal to 0. I like to write it this way, x squared plus minus 2x plus 6 equals 0. And now if I could factor it, I would factor, and this one does not factor. So I have two other options. I could complete the square, or I can use the quadratic formula. I'm imagining most people will go ahead and use the quadratic formula. So I'm going to figure out what b squared minus 4ac is first, because that's the part that goes underneath the square root. Since b is negative 2, b squared will be 4. Then I have minus 4 times ac. A is 1, c is 6, so that's times 6. So what's going on here? I have 4 minus 24, which is negative 20. This poses a problem because I would be putting negative 20 underneath the square root in the quadratic formula. So it's not going to be a real number, and all the numbers on the x-axis are real numbers. So this means there are no x-intercepts. Now what does that mean? If there are no x-intercepts, it means either the entire parabola must be above the x-axis or below it. So you could convince yourself what's going on by drawing a little picture if you'd like so that it does make sense. So let's say I have x and y. I know the y-intercept appears, let's say, at 0, 6. And this parabola is going up, isn't it? Because the coefficient of x squared is positive, so that's why you're never going to go through the x-axis. We don't know how this is going up exactly, but we do know it's a parabola going up, where the very bottom, the minimum, is down here at the order pair 0, 6. And so for this parabola, the y-intercept is 0, 6, and there are no x-intercepts. Now, I want to go back to solving this quadratic equation. Notice I did not even need to put it in the quadratic formula because once I found out the discriminant was negative, I know there's no real solutions, and that means there are no x-coordinates. No x-intercepts. The other way you could have done this, for those of you who prefer to complete the square, is write x squared minus 2x. We know we're going to put plus something, and negative x plus something on the other side. And if you complete the square, we get x minus 1 squared. We'd be adding 1 to both sides equals negative 5. And we have a problem right here because you can't have something squared. You can't have a real number squared equaling a negative number. So if you tried to take the square roots of both sides here, notice we would get x minus 1 equals plus or minus the square root of negative 5. Well, that's the square root of 5i. So x equals 1 plus or minus the square root of 5i. There is no I on the x-axis. So even though there are values for x, these are not X-intercepts. So there's another way you could do it and determine there's no X-intercepts. So there are two values of X, but they are complex. They include an imaginary part, so they are not on the x-axis. So again, we would get no x-intercepts. So for this problem, we did find the y-intercept, and that was it. There's no x-intercepts, and we got that the y-intercept, when we put in 0, remember we got 6. So that's the information for this parabola. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.